Okay, so this time our topic is cloud computing and related to enterprise architecture, no? So the whole idea of enterprise architecture is to enable the enterprise to address orders of magnitude increases in complexity and orders of magnitude increases in the rate of change. Now, therefore, if you have enterprise architecture and if you have made that enterprise architecture explicit and if you have designed it correctly, you should be able to change the enterprise and or its formalism. No, that is its systems, manual or automated, with minimum time, minimum disruption, and minimum cost. So of course, we want to change the manual material handling aspect of your enterprise based on cloud computing, and you may want to change your strategic on-core system. However, if we wanted to change any automated system and you have enterprise architecture designed for accommodating complexity in change, then you should be able to move the enterprise record off-site to run the different data storage technologies and different database management system products. No? We need to redefine the transaction flow, restructure the data network, reallocate the responsibility, redefine the control structure, and you can change technology motivations. To give us more details about the topic, let us all welcome our presenter.
Good afternoon, everyone. My name is Joven Cosico, and I'm presenting Lesson 16, Cloud Computing. Cloud Computing. Cloud computing is a system that allows sharing of information, software, and resources. A server network connected by the internet makes this possible. Its main function is to share information, resources, and software. The internet acts as invisible cable that connects everything. This includes all physical and virtual servers all over the globe. Thus, we can compare the functionality of the cloud computing to a cloud. It has unlimited means to travel the globe. This is the first way we can define cloud computing. Cloud computing is on-demand accessibility of computer resources. In simpler terms, cloud computing refers to the idea of using network of remote servers on the internet to accumulate, manage, and route the data. Delivering any computing services on the internet is a cloud computing. These cloud computing services can be storage, server, database, software, networking, intelligence, and analytics. When we say on-demand accessibility, it nurtures the idea of only paying for the services you are using. Businesses are adopting cloud computing for its multifold benefits like minimizing capital expense, on-demand self-services, global scalability, optimum performance, security, high productivity, and reliability. There are three main cloud service delivering models. First, software as a service, also known as SaaS. SaaS offering cloud computing services via licensed software or subscription. In this delivery model, the end users don't need to buy or install any hardware at their locations. Some key benefits of SaaS include its lightweight. Running SaaS application does not typically require as many computing resources as on-premises software. No need for software updates. Vendor manage and update SaaS application. That means everyone has access to the most up-to-date version at all times. No more software licensing. Premium SaaS application follow the subscription model, which means you don't have to worry about buying and renewing software licenses. Next is infrastructure as a service, also known as IaaS. This model facilitates computer hardware, like networking technology, servers, storage, and data centers, space as a service. It also includes the delivery of virtualization technology and operating system. Benefits of using EAS include greater flexibility. EAS lets you access infrastructure service on demand. You can scale infrastructure to support business growth and reduce it when needed. Cost saving. You don't have to buy physical hardware every time you want upgrade. Your computing infrastructure is provided on a subscription basis, meaning your vendor is the one responsible for infrastructure management. Reliability. Your assets are stored in a remote data center where it's managed by cloud service provider. These service models all but eliminates the threat of a single point of failure. Next is Platform as a Service, also known as PaaS. This model offers a platform that allows the end user to develop, run as well as manage application on the cloud. In PaaS, a third-party service provider facilitates hardware and software tools. Benefits of PaaS include improved efficiency. Since a third party handles your IT infrastructure needs, businesses can spend more time focusing on developing, testing, and deploying applications. Simplicity. PaaS give businesses a platform with development tools so they can develop, test, and host application in the same environment. Better collaboration. FAAS require teams to develop over the internet, eliminating the need to transfer files and manually sync data. Everyone works with the same up-to-date. Cloud computing architecture. Components of cloud computing architecture. The fundamental components of the cloud computing architecture are front-end platform. What is front-end cloud architecture? The front-end infrastructure includes everything that the end user interacts with. It is the broader assimilation of various subcomponents that together offer the user interface, and it forms an essential part of how the end cloud infrastructure includes components like local networks, web browsers, and web application. The main front-end cloud components are user interface. The user interface refers to all the things that end user access to send requests or perform any task on the cloud. Some of the popular cloud-based user interface are Google Docs, Gmail, etc. Software. The software architecture in the front end is the software that runs on the user's end. Front-end software architecture primarily comprises client-side application or browsers. Client devices or network being a crucial part of the front-end architecture. Client device or network refers to the hardware at the end user side. It can be any input device or PC in cloud computing. The client-side device does not require extraordinary ability to process the heavy load. The cloud can take the entire heavy load and process the same. Next is back-end platform. What is backend cloud architecture? The backend architecture in the cloud empowers the front-end architecture. It comprises hardware and storage, and they are located on a remote server. The cloud service provider controls and handles this backend cloud architecture. Ideal backend cloud architecture always should be robust as it holds the whole infrastructure on the cloud. The prime components of backend cloud architecture are application. The application is substantial part of the backend. architecture. It refers to the user interface that the backend offers to the end users to send queries. This layer of the backend takes care of client requests and requirements. Service. This is a magical area of the backend cloud architecture. It adds utility to the entire backend architecture. The service handles every task that runs on the cloud computing system. Some of the cloud services are application developed environment. Storage and web services, besides service, can execute a wide array of tasks on the cloud runtime. Cloud runtime, the term cloud runtime is the concept where the service run. It's like a cloud operating system where technology like virtualization is used. Virtualization as the key technology on the cloud which allow multiple runtime on the same server. For instance, virtualization is a way via which we can create a base of software. In a simple words, it's a virtual representation of apps. Server storage as well as network. When we create runtime with the support of virtualization software, they are called a hypervisor. Some of the leading hypervisor are Oracle VirtualBox, Oracle VM, or VMware Fusion, etc. Next is storage. The storage of the cloud is where the data resides of the cloud application. The data storage varies as per different cloud service provides. However, all of them have common dedicated segment for cloud storage. Some of the example of storage are solid-state drives, hard drives, Intel Optane DC, persistent storage, etc. The hard drive in the server base for storage in the cloud, backend architecture, and especially in the cloud computing system. The software partition the drives as per the needs of the OS cloud to run myriad services and infrastructure. The engine that steers all the cloud software services is called infrastructure. It includes CPU, motherboard, graphics processing unit, GPU, network cards, accelerator card, etc. Types of cloud computing. First, public clouds. Public clouds are cloud environments typically created from IT infrastructure not owned by the end user. Some of the largest public cloud providers include Alibaba Cloud, Amazon Web Services, Google Cloud, IBM Cloud, and Microsoft Azure. Traditional public cloud always run off premises, but today's public cloud providers have started offering cloud services on client on-premises data centers. This has made location and ownership distinction obsolete. All clouds become public clouds when the environments are partitioned and redistributed to multiple tenants. Next is private cloud. Private clouds are loosely defined as cloud environments solely dedicated to a single end user or group, where the environment usually runs behind that user's or group firewall. All clouds become private clouds when the underlying IT infrastructure is dedicated to a single customer with completely isolated access. But private clouds no longer have to source from on-prem IT infrastructure. Organizations are now building private clouds on rented, vendor-owned data centers located off premises, which make any location and ownership rules obsolete. This has also led to a number of private cloud subtypes. Next is the community cloud or multi-clouds are the cloud approach made up more than one cloud service from more than one cloud vendor, public or private. All hybrid clouds are multi-clouds, but not all multi-clouds are hybrid clouds. Multi-clouds become hybrid clouds when multiple clouds are connected by some form of integrate or orchestration. A multi-cloud environment might exist on purpose to better control sensitive data or as a redundant storage space for improved disaster recovery or by accident. usually the result of shadow IT. Either way, having multiple clouds is becoming more common across enterprise that seek to improve security and performance through an expanded portfolio of environment. And lastly is the hybrid clouds. A hybrid cloud is simply single IT environment created from multiple environments connected through local area network, wide area network, virtual private network, and or APIs. The characteristic of hybrid clouds are complex and the requirements can differ depending on whom you ask, but every IT systems become a hybrid cloud when apps can move in and out of multiple separate yet connected environments. At least a few of those environments need to be sourced from consolidated it resources that can scale on demand, and all of those environments need to be managed by a single environment using an integrated management and orchestration platform. Examples of cloud computing. First, Dropbox, Facebook, Gmail. Cloud can be used for storage of files. The advantage is an easy backup. They automatically synchronize the files from the desktop. Dropbox allowing user to access files and storage up to 1 terabyte of free storage. Social networking platforms require a powerful hosting to manage and store data in real time. Cloud-based communication provides click-to-call capabilities from social networking sites, access to the instant messaging system. Next is the banking financial services. Consumers more financial information to cloud computing services providers. They store tax records as online backup services. Third is healthcare. Using cloud computing, medical professionals host information, analytics, and do diagnostic remotely. As healthcare also comes in the list of example of cloud computing, it allows other doctors around the world to immediately access this medical information for faster prescription and updates. Application of cloud computing in healthcare includes telemedicine, public and personal healthcare, electronic health services, and bioinformatics. Fourth, education. This is useful in institutions of higher learning, provide benefits to universities and colleges. So, henceforth, education come in the example of cloud computing. Google and Microsoft provide various services free of charge to staff and students in different learning institutions. Several educational institutions use them to improve efficiency, cut on costs. Example, Google Apps, Education. They allow the user to use their personal workspace. Teaching becomes more interactive. Fifth, government. They deliver e-governance services to citizens using cloud-based IT services. They have the technology to handle large transactions. Citizens can see fewer congestion bottlenecks. 6. Big data analytics. Big data analytics is another example of cloud computing, as cloud computing enables data scientists. It analyzing their data patterns, insights, correlation, prediction, and help in good decision making. There are many open sources of big tools like Hadoop, Cassandra. And lastly, communication. Cloud allows network-based access to communicate tools like emails and calendars. WhatsApp is also a cloud-based infrastructure as it comes in communication. It is also one of the example cloud computing. All the messages and information are stored in services providers hardware. 8. Business process. Business process is the business email is cloud-based ERP, document management, and CRM are based on a cloud services provider SaaS has become an important method for the enterprise. Example includes Salesforce, HubSpot. They make many business process more reliable because data can be copied at multiple redundant sites on the cloud providers. The top 7 application of cloud computing. Online data storage. Cloud computing allows storage and access to data like files, image, audio, and videos on the cloud storage. In this age of big data, storing huge volumes of business data locally requires more space and escalating costs. This is where cloud storage come into play where businesses can store and access data using multiple devices. The interface provided is easy to use, convenient, and has the benefits of high speed, scalability, and integrated security. Next is backup and recovery. Cloud service providers offer safe storage and backup facility for data and resources on the cloud. In a traditional computing system, data backup is a complex problem and often in the case of disaster. Data can be permanently lost, but with the cloud computing data can be easily recovered with minimal damage in case of disaster. Third, big data analysis. One of the most important applications of cloud computing is its role in extensive data analysis. The extremely large volume of big data makes it impossible to store using traditional data management system. Due to unlimited storage capacity of the cloud, businesses can now store and analyze big data to gain valuable business insight. Fourth, testing and development. Cloud computing application provide the easiest approach for testing and development of product. In traditional methods, such as an environment, would be time-consuming, expensive due to the setting up of IT resources and infrastructure, and need manpower. However, with cloud computing, businesses get scalable and flexible cloud services, which they can use for product development, testing, and deployment. Fifth is the antivirus application. With cloud computing comes cloud antivirus software which is stored in the cloud from where they monitor viruses and malware in the organization system and fixes them. Earlier organizations had to install antivirus software within their system and detect security threats. 6. The e-commerce application. E-commerce application in the cloud enables users and e-business to respond quickly to emerging opportunities. It offers a new approach to business leaders to make things done with minimum amount and minimal time. They use cloud environments to manage customer data, product data, and other operational systems. And lastly is the cloud computing in education. E-learning, online distance learning programs, and student information portals are some of the key changes brought about by application of cloud computing in the education sector in this new advantages of cloud computing. Backup and restore data. Once the data is stored in the cloud, it's easier to get backup and restore the data using the cloud. Improve collaboration. Cloud application improve collaboration by allowing groups of people to quickly and easily share information in the cloud via shared storage. Third, excellent accessibility. Clouds allow us to quickly and easily access store information anywhere, anytime in the whole world, using an internet connection. An internet cloud infrastructure increases organization, productivity, and efficiency by ensuring that our data is always accessible. Low maintenance costs. Cloud computing reduces both hardware and software maintenance costs for organizations. Fifth, mobility. Cloud computing allows us to easily access all cloud data via mobile. 6. iServices in the pay-per-use model. Cloud computing offers application programming interface APIs to the user for access services on the cloud and pays the charges as per usage of service. 7. Unlimited storage capacity. Cloud offers a huge amount of storage capacity for storing our important data such as documents, image, audio, video, etc. in one place. Data security. Data security is one of the biggest advantages of cloud computing. Cloud offers many advanced features related to security and ensures that data is securely stored and handled. Disadvantage of cloud computing. First, downtime. Downtime is often cited as one of the biggest disadvantages of cloud computing. Since cloud computing systems are internet-based, service outages are always an unfortunate possibility and can occur for any reason. Next, security and privacy. Although cloud service providers implement the best security standard and industry certification, storing data and important files on external service provider always open up risk, and any discussion involving data must address security and privacy, especially when it comes to managing sensitive data. We must not forget what happened at the code's face and hacking of their AWS EC2 console, which led to data deletion and eventually shutdown of the company. Their dependence on a remote cloud-based infrastructure mean taking on the risk of outsourcing everything. Third is the vulnerability to attack. In cloud computing, very component is online which exposes potential vulnerabilities. Even the best teams suffer severe attacks and security breaches from time to time. Since cloud computing is built as a public service, it's easy to run before you learn to walk. After all, no one a cloud vendor checks your administration skills before granting you an account. All it takes to get started is generally a valid credit card. Fourth, limited control and flexibility. Since the cloud infrastructure is entirely owned, managed, and monitored by the service provider, it transfers minimal control over to the customer. To varying degree, depending on the particular service, cloud user may find they less control over the function and execution of services within a cloud-hosted infrastructure. A cloud provider's end users license agreement and managed policies might impose limits on what customer can do with their deployment. Customers to retain control of their application data and services but may not have the same level of control over their backend infrastructure. Fifth, vendor lock-in. Vendor lock-in is another perceived disadvantage of cloud computing. Easy switching between cloud services is a service that has not yet completely evolved, an organization may find it difficult to migrate their services from one vendor to another. Differences between vendor platforms may create difficulties in migrating from one cloud platform to another, which could equate to additional costs and configuration complexities. Gaps or compromises made during migration could also expose your data to additional security and privacy vulnerabilities. 6. Cost concern. Adapting cloud solution on a small scale and for short-term projects can be perceived as being expensive. However, the most significant cloud computing benefits is in terms of IT cost saving. Pay as you go. Cloud services can provide more flexibility and lower hardware costs, but the overall price tag could end up being higher than you expected until you are sure of what will work best for you. It's a good idea to experiment with a variety of offering. You might also make use of the cost. Calculators made available by providers like Amazon Web Services and Google Cloud Platforms. That's all my presentation and thank you for listening.
Okay, so thank you very much. No, again, cloud computing is a useful technology, no, alternative for implementing our enterprise, no, and it affect the implementation to minimize the risk and maximize its utility, no, because the fundamental enterprise architecture is to answering with more appropriate, of course, implementations. And we need to add one or more implementation to the legacy, no, of systems and likely reacting something that is already implemented, no. Adding general and administrative costs, additional ongoing operating expenses to the enterprise reconciling, no, the new implementation of existing systems, no. Increasing the, how do you call this one, existing complexity of business operations and inhibiting subsequent changes. No, again, the cloud, no, or enterprise architecture, it examines enterprise architecture in the context of the surging popularity of cloud computing. No, it explains the different kinds of desired transformation the architectural blocks of EA undergo in the light of this strategically significant convergence. No. Cloud computing architectures, of course, is refer to the components and subcomponents required for cloud computing. And these components typically consist of a front-end platform like fat client, thin client, mobile, and of course the back-end platforms like servers and storage. Because a cloud-based delivery in a network like internet or either intranet pa yan or intercloud, no? The most 6 basic elements of enterprise architecture, we have the framework, no, we have the management, the documentation artifacts, no, the repository of architecture, and the associated best practices of enterprise architecture. And we need to accept the fact that it helps, no, the cloud computing architecture helps businesses to easily scale up and scale down their cloud resources. It has a flexibility features which give businesses a competitive advantage. It results in better disaster recovery and provide high security because it automatically updates its services, di po ba? Then, again, as I mentioned, no, earlier, and our presenter mentioned, cloud computing architecture is simple. No, it clearly states the components and subcomponents embedded in it. No, there's no questions. The cloud computing here to stay. No, it touches every part of our lives today offering many advantages in terms of flexibility, storage, sharing, maintenance, and much more. So a standard in internet connections or a virtual network provides us access to cloud-based applications and services like Google Docs, Skype, and Netflix. No, and most companies are shifting their businesses into the clouds as they require significant storage, which cloud platforms provide, because a cloud computing architecture provides higher bandwidth to its users, due to which data over the cloud can be used from anywhere across the world at any time. Due to its architecture, it not only shares resources among client source consumer, but also with open source communities like Microsoft and Red Hat. No, but how exactly does cloud computing work? Again, cloud computing refers to the services like storage, databases, software, analytics, and other platforms that are accessible via the internet. No, it is any services that can be delivered without being physically close to the hardware. No, another example, of course, no, for example, yung Netflix uses cloud computing for its video streaming services. Another example is the G Suite, no, which runs entirely on the cloud. Simply put, cloud computing refers to the delivery of the demands, delivery of on-demand resources such as server, database, software over the internet. It also gives the ability to build, design, and manage application on the cloud platform. No. So I think the most popular cloud computing right now when it comes to service provider is the Microsoft Azure, AWS, no, the Amazon Web Services, Google Cloud, no, Alibaba Cloud, IBM Cloud, Oracle, Salesforce, no, SAP, no, the SAP, Rackspace Cloud, and of course the VMware, no. So our presenter mentioned that wait. So our presenter mentioned that the cloud computing architecture is divided into two parts, no, front end and back end. No, so the front end and back end communicate via a network or the internet. So a diagrammatic representation of cloud computing architecture. Of course, we have the management, the cloud infrastructure, the security, covering the internet with application, service, and storage. Okay. So I think you have an idea actually. So some benefits of cloud computing architecture is designed in such a way that it solves latency issues and improves data processing requirements. No, it reduces IT operating costs and gives good accessibility to access data and digital tools. No, so it helps businesses to easily scale up and scale down their cloud services, or resources. It has flexibility features, which give businesses a competitive advantage. It results in better disaster recovery and provides high security. It automatically updates its services. It encourages remote working and promotes team collaboration. So going ahead, let's of course we have the cloud computer architecture components. We had, of course, the hypervisor. We have the management software, deployment software, network, cloud server, and cloud storage. So again, cloud computing architectures gives an environment where organizations can securely build applications and use cloud services based on the client requirements. So with this, we got a complete rundown on the cloud computing architecture. And in this discussion, we learned that cloud computing is the benefits of cloud computing architecture, the architecture of cloud computing, and components of cloud computing architecture. So even the cloud architect who wants to understand Amazon Web Services in depth, of course, can, I think, maybe give more emphasis on how you'll be able to learn some master's program related to cloud computing. It is custom, actually there is certain custom made a mastering of AWS, cloud architect techniques and strategies. So again, I think that's it for this topic.